Deep within the secluded corners of tropical islands, a creature of truly astonishing proportions resides. Imagine an animal that can weigh more than a newborn human, with a leg span exceeding 3 feet. This is the coconut crab, Birgus latro, the undisputed heavyweight champion of all land-dwelling arthropods. Its mere existence challenges our perception of how large a land invertebrate can become, sparking a fascinating inquiry into the specific conditions and characteristics that enabled such an incredible feat of nature. We journey to understand the unique pathway that led to this crab's colossal dimensions. Unlike most crabs tied to the ocean, the coconut crab has made a profound commitment to terrestrial life. While its ancestors were marine, this remarkable creature has developed a suite of adaptations that allow it to thrive almost entirely on land, returning to the sea only to release its eggs. This departure from aquatic dependence is a foundational element in its journey to immense size. Living on land offers different resources and environmental pressures, paving the way for a distinct growth trajectory, distinct from its saltwater relatives who face different challenges and opportunities for sustenance and expansion. Early in its life, the coconut crab resembles its hermit crab relatives, using discarded shells for protection. However, as it grows, a significant transformation occurs. It abandons this external shelter, hardening its own abdomen into a robust, calcified armor. This is a critical transition. An external shell would become too cumbersome and energy-intensive to maintain at such large sizes. Developing its own hardened carapace freed it from the limitations of finding increasingly larger vacant shells, allowing for continuous and unconstrained growth, truly setting it apart in its lineage and enabling its enormous potential. To survive on land, the coconut crab required a specialized respiratory system. Its gills, common among aquatic crabs, have been significantly modified into lung-like structures, sometimes called branchiostegal lungs. These organs are highly vascularized and capable of extracting oxygen directly from the air. However, these modified lungs still require a humid environment to function effectively, which is why coconut crabs prefer moist tropical forests and often retreat to burrows during dry periods. This remarkable internal architecture is essential for supporting its immense body on land, a testament to its successful adaptation. Growth for an arthropod like the coconut crab is a monumental and dangerous undertaking. To increase in size, it must shed its rigid exoskeleton in a process called molting. This leaves the crab soft and vulnerable for several weeks, forcing it to seek refuge in a secure burrow. During this critical period, it rapidly absorbs water, swelling its body to expand its new, soft cuticle. Once the new shell hardens, the crab has achieved a larger size. This slow, incremental process, repeated throughout its long life, is the physical mechanism by which it accumulates its impressive mass. What does it take to fuel such a massive creature? The coconut crab is an omnivorous scavenger with a particularly strong appetite for high-energy foods. Its diet famously includes coconuts, which it cracks open with astonishing strength. But it also consumes fruits, nuts, seeds, carrion, and even other crabs. This diverse and calorie-rich diet, abundant in its island habitats, provides the necessary energy and nutrients to sustain its substantial metabolism and facilitate its prolonged growth phases. Access to such high-quality sustenance is a cornerstone of its ability to reach epic proportions. The coconut crab's most striking feature, beyond its size, is undoubtedly its colossal claws. These aren't just for show, they are tools of immense power, capable of generating gripping forces up to 3,300 newtons, among the strongest forces recorded in any animal. This incredible strength is crucial for its survival, allowing it to crack open tough coconuts, climb trees to forage, and provide a formidable defense against potential threats. Without these specialized appendages, accessing its primary food source would be impossible, and its impressive size could not be maintained or protected. The remote island habitats favored by coconut crabs offer a unique advantage, a relative scarcity of large terrestrial predators. On many of these isolated atolls, animals that would typically prey on large land arthropods are absent or present in limited numbers. This reduction in predation pressure allows the crabs to grow to larger sizes without facing constant threats. While they still face challenges, this environmental characteristic enables them to invest more energy into growth rather than solely into defense or evasion, providing a critical condition for their unparalleled scale. Reaching such an impressive size takes time, and the coconut crab has an abundance of it. These creatures are remarkably long-lived, with some individuals estimated to live for 40 to 60 years. This extended lifespan allows for numerous molting cycles, providing ample opportunity for incremental growth throughout their decades. A shorter lifespan would simply not permit the accumulation of the necessary mass to become the largest land arthropod. Their longevity is a fundamental factor in achieving and maintaining their colossal dimensions, a direct contributor to their position at the top of the size charts. The sheer volume of chitin and calcium carbonate required to construct and regenerate such a massive exoskeleton is staggering. Coconut crabs must efficiently source these essential minerals from their environment. They achieve this by consuming fallen shells of other crustaceans, bones, and even their own shed exoskeletons after molting. This behavior ensures a constant supply of calcium, vital for hardening their new shells and sustaining their large body structure. The ability to reclaim and reuse these precious building blocks is an efficient strategy for supporting their enormous, calcified armor. While they possess large eyes, the coconut crab primarily relies on its highly developed sense of smell to navigate its environment and locate food. Its specialized antennae are incredibly sensitive, detecting the scent of ripe fruit, decaying matter, or even distant coconuts. This keen olfactory ability allows it to efficiently forage across vast areas of its island habitat, even in darkness. This sensory proficiency ensures consistent access to the energy-rich diet needed to fuel its substantial growth and maintain its impressive size, a crucial element in its successful life strategy. Despite their land-dwelling existence, the life cycle of the coconut crab begins in the ocean. Females migrate to the shoreline to release their thousands of fertilized eggs into the sea. The larval stage, lasting several weeks, is entirely aquatic, drifting as plankton before settling and metamorphosing into tiny hermit crabs. This oceanic nursery allows for wide dispersal across islands, colonizing new habitats where conditions are favorable for growth. This dual habitat strategy, starting small and spreading wide in the sea, is essential for the species' propagation and continued presence across its range. One of the greatest challenges for a large land animal is water regulation. While coconut crabs need humidity for their modified gills, they don't drink water in the conventional sense. Instead, they absorb water from moist soil, dew, and by eating water-rich foods. They also have specialized organs that extract water from brackish pools and store it in their branchial chambers, acting as internal reservoirs. This sophisticated water management system is key to their independence from open freshwater sources and enables them to thrive in environments where water can be scarce, supporting their massive body functions. Coconut crabs are largely solitary creatures, avoiding direct competition for resources within their territories. While they can be found in groups in areas of abundant food, they generally maintain their own foraging grounds. This solitary nature reduces intraspecific competition, ensuring that individual crabs have sufficient access to the high-energy diet required to fuel their prolonged growth. Such a behavioral strategy, minimizing direct conflicts over food and space, allows for more efficient resource utilization, a contributing factor to the robust size achieved by these magnificent arthropods. Despite their formidable size and strength, coconut crabs are surprisingly vulnerable to human activities. Habitat loss, largely due to development and deforestation on their native islands, poses a significant threat. They are also susceptible to overharvesting for food and the pet trade. Their slow growth rate and long lifespan mean that populations are slow to recover from declines. This delicate balance highlights that while nature has equipped them for immense size, their continued existence as the largest land arthropods depends heavily on our understanding and protection of their unique habitats and life cycles. Recognizing the unique status and vulnerability of the coconut crab, conservation efforts are underway in various parts of its range. These initiatives focus on protecting critical breeding grounds, establishing marine protected areas for larval dispersal, and educating local communities about sustainable practices. Understanding the complex interplay of their unique adaptations, specific dietary needs, long lifespans, and ideal environmental conditions is crucial for effective conservation. By safeguarding their habitats and managing human interaction, we can ensure that future generations continue to witness the awe-inspiring presence of the world's largest land arthropod. The coconut crab stands as a living marvel, a testament to the diverse pathways life can take when presented with particular environmental conditions and a unique set of physical capabilities. Its journey to becoming the largest land-dwelling arthropod is not one of mere chance, but a story woven from specialized respiratory systems, immense claw strength, a diet rich in energy, a prolonged lifespan, efficient nutrient recycling, and the sanctuary of remote islands. It exemplifies how specific biological mechanisms, in concert with an accommodating habitat, can shape a creature into a true giant, forever captivating our imagination and deepening our appreciation for the natural world.